Bismillahirrahmanirrahim. Students, welcome to the virtual session of System Analysis and Design. It's week 7, and the topic for this week was data modeling. And we talked about data modeling, different diagrams used for data modeling. One of the most important diagrams used for data modeling is entity relationship diagram. We talked about how we can draw entity relationship diagram and what are the steps involved, how we can identify entities. So in today's session, I'll give you a brief review of the things we have studied in class, in our face-to-face class, and then you are welcome to ask any question if you find any from these slides. So let's continue. Sorry, I forgot to ask, if you can hear me properly, please raise your hand. Okay, that's fine. Thank you. Okay, now let's continue with what we have studied in class. We talked about data modeling. So in previous week we were talking about process modeling, and I told you that how we can draw data flow diagrams that we practiced on using some of the examples in our previous virtual session. So today we are going to talk about data modeling, and here there are a few things which should be clear. One thing is, what is data model? It is a way of representing the data that are used and created by the business system. So what your system you are going to develop, the system is the data the system is going to use, or with the data which system has produced. You want to model that data, and you want to show the people, places, things, or events about which the data is captured and the relationship among those data items. So if you make such a model, this is called data model. So there can be two models, logical and physical. Logical shows the organization of data without indicating how it is stored, created, and manipulated, whereas physical data model shows how the data will actually be stored in databases and files. After making your data model, after making your entity relationship diagram, which we'll be talking about in a short while, we perform the process of normalization, which is used to validate your data model. So you want to check that whether your data model is correct or not, then you perform. For this purpose, you perform normalization. So the entity relationship diagram, which is the diagram which is used to model your data in your system. So it is a picture showing the information created, stored, and used by the business systems. And entities represent similar kinds of information. So if you have different instances, like for example a group of people about whom you want to store data, so you can make an entity like person or people, and you'll be recording information about them. And that group will be called an entity, and with the label of person. So you can draw lines between entities to show relationships among the data items as well. And high-level business rules are also known in your data flow diagram, in which you can say, like for example, if you are making an entity relationship diagram for patient and doctor. So if there is that one doctor can see many patients, but one doctor can see, one patient can see one doctor. So if there are certain rules followed in your system and in your organization, so you can implement those rules, and you can implement whether the entity is optional or it is mandatory. So you can apply, or you can place all these constraints and all these rules in your system, and these can be realized using your entity relationship diagram. Then you can show that if whether one instance of an entity can be related to only one or many instances of the other entity, which is called cardinality. And also you can show when the existence of entity instance is optional or it is mandatory. So you can do it, when you do this, it is called modality. So you can show cardinality and modality both in your entity relationship diagram. This is one example of a entity relationship diagram in which there are blue boxes showing entities like doctor, appointment, patient, insurance company, payment, bill. So as you can see that the title of entity is placed over the top, and the other attributes of those entities. For example, the attribute of doctor are doctor, physician, ID number, doctor first name, doctor last name, doctor address. So these are the attributes of doctor which are placed in the box below this block inside this is an entity. And similarly, you can see that there are certain lines which are linking these boxes. These lines are actually representing relationship. And which relationship? The relationship title is written over the line. For example, doctor is scheduled by or includes appointment. An appointment schedules or is scheduled by patient. And similarly, bill is generated. Appointment generates bill or is generated by appointment. So this is the relationship existing between them. And then you can see that there are certain symbols which are indicating either these symbols are actually the symbols are used to represent cardinality and modality, which we'll be talking about in a short while. Now you can use different notations to make your entity relationship diagram. Like the entity, the three different notations shown over in this table. Like you can mention entity name in this box, your attributes over here, and the relationship in this way. Or you can make a diamond shaped symbol to represent relationship in chain notation, and attribute name can be represented through an oval. So there are different notations which you can use, but if you are using one set notation, one particular notation, then you should stick to that. You should not use multiple notations in a single diagram. So entity is a person, place, event, or thing about which the data is collected, but it is important that there must be multiple occurrences of an entity. For example, if a firm has only one warehouse, then it is not an entity. However, if the firm has several warehouses about which you want to record data, then you can say that warehouse is an entity. The relationship between entities and instances like this, like for example, entity is patient, and if you say that the patient names are John Smith, Susan Jones, Peter Todd, so these are the instances of patient entity. Then attributes represent the information captured about the entity. For example, if you are talking about patient ID, patient name, patient age, first name, last name, so these are the attributes about patient. So mostly these are nouns. And sometimes to differentiate among attributes of two different entities, for example, the name can be name of a doctor and name can be name of a patient. So sometimes you add the prefix of entity name before this name at the beginning of attribute name for clarity. And some IDs, which are called primary keys, sometimes are used to identify uniquely each entity instance. So in an entity, the attribute which is picked up as a unique identifier or a primary key should be unique among all the instances. You can use concatenated identifier as well, which is sometimes called composite primary key, which is made up of multiple keys. So you can use that as well. And then relationships among the entities can be parent-child relationship as well, which is called generalization or specialization. We talked about them previously. So this can have the relationships can exist among entities as well. And then cardinality can be refers to the number of times instances in one entity can be related to instances in another entity. So these are one-to-one, one-to-many, and many-to-many. And there are many-to-one as well, which is not mentioned here. Then modality refers that whether or not an instance of a child entity can exist without a related instance in the parent entity. So if we say it's not null, it means that an instance in the related entity must exist for an instance in another entity to be valid. So the existence is mandatory. If we say it's null, it means no instance in the related entity is necessary for an instance in another entity to be valid. So there can be a zero instance of an entity. There can be a zero instance of an entity participating in a relationship with the other entity. So the existence is mandatory, we call it null, and if it is mandatory, it is optional, we call it null, and if it is mandatory, we call it not null. So you can represent multiple relationships in this way, like in case of first like the same. For example, if you see the above the upper diagram, you can see that patient and symptom. So here this 0 is actually, or this small circle is actually indicating modality. So here we can say that there can be 0 patients. There can be a patient with no symptom, or there can be a symptom with 0 patient associated with that. So there can be a symptom in this symptom entity which none of the patient is carrying, and there can be a patient or here carrying none of the symptoms listed in symptom entity. So this is the modality which is null, like optional. Now if we see this symbol, which is a small line, or you can say 1 as well, small line at the end of this actually indicates the not null value, like mandatory, that there should be at least one doctor who's qualified in a specialty from this, and there should be at least one specialty. There should be at least one specialty for which a doctor is associated with it. So there cannot be a doctor having no specialty, and there cannot be a specialty over here having no doctor associated with. So this is the mandatory participation of both the entities. Then you make a data dictionary, and you keep the metadata, which is data about data. It is because this is keeping the information about the data model, about the components of different data models. So this metadata is stored in the data dictionary, so it can be shared by developers and users throughout the SDLC. So a complete shareable data dictionary helps improve the quality of systems under development. So you can make a data dictionary entry for patient entry in this way using Erwin. This is one sample view which has been taken from there. So whenever you have to draw an entity relationship diagram, so you cannot say that once you have drawn an ERD to the final ERD, you have to keep on revising it until you get the final diagram. So this can be quite complex as well. There are certain steps involved in building up the ERD. The first is to identify the entities. So identify all those things, places, persons, events in your system about which you need to record data. And if they are having multiple instances, then it means they are candidate to be an entity. Make them an entity, then add attributes, and then after adding an attribute, identify the attribute which is unique, which is different for everyone. For example, patient ID will be different for every patient. So that will be a unique identifier. Then you identify the relationships, like what kind of relationships are there among those entities. So by seeing their communication from the data flow diagram, you can see that how they are linked with each other. So you can identify relationships. So this is what I have already talked, so I'm going to skip this. Now the things which you need to verify is that data source of data flow diagram should correspond to entities, and only include entities with more than one instance of information. Do not include entity associated with implementation of the system. So you do not need to go into too much details of implementation level. So you need to just see your system as a whole over here. There can be independent and dependent entities. The independent one can exist without the help of another entity. And dependent entity is the one like a child having the parent-child relationship. For example, the relationships where a parent entity does not require attribute from the parent entity to uniquely identify an instance. So if it is depending, if it's using some attribute in its primary key which is from some other entity, then it is a dependent entity. Because to uniquely identify each of the instance, it needs help from the other entity, because it is using the attribute of the other entity in its composite primary key. So that will be a dependent entity. Then there can be intersection entity as well, which is there just to capture some information about the relationships that exist between two entities. And mostly we add intersection entities in the entities which are having many-to-many relationships. We cannot have or we avoid having many-to-many relationships in our entity relationship diagram. So whenever two entities are having a many-to-many relationship, you need to resolve that. To resolve that, what you do is you introduce an intersection entity. For example, if you see here, in this diagram, both are actually representing the same. The upper diagram is showing the many-to-many relationship between patient and symptom entities. And when you resolve this by introducing an intersection entity, which is this one, which you are calling patient symptom, so now this many-to-many relationship is resolved, and you have this entity which is now this is having one-to-many relationship and many-to-one relationship. So now let's see the attributes you have kept here. In patient symptom, you have kept patient ID number, the primary attribute from patient, and you have kept the symptom name, the primary attribute of symptom entity. And you have kept another attribute which is the PS date, like patient symptom date, the date at which you have recorded this. So this is the intersection entity which has been introduced to resolve many-to-many relationships. So you can introduce such relationships in your entity relationship diagram. Now, once you have made your entity relationship diagram, your job is not done. You have to validate your entity relationship diagram as well. So sometimes you use certain certain guidelines or certain rules to validate your entity relationship diagrams, and then using these guidelines, most of the problems are resolved. But then at the later stage, after doing all this, you have to check your ERD for different normal forms as well. So first of all, let's see. I didn't explain this slide in my face-to-face class. I wanted you to listen to me and pay attention over here. So there are certain problems in this entity relationship diagram. So let's see first one, like country is an entity with an attribute country name. Now country has only one instance, so this entity is not needed. So if there is an entity having only one instance, so you don't need to make this entity, so this should be eliminated. Now let's talk about the second one. If you are calling teachers as professors in your system, then the entity relationship diagram should also contain an entity called professor to remain consistent. Instead of calling it teacher, you should call them professor. So the system you are going to develop, if it is you're using certain terms, like for teachers, if the system is calling them professors, then in your entity relationship diagram, we should call them professor instead of teachers. Now, the third is, if you see this university, there are certain attributes: university name, enrollment, date founded, university founder, university first president. The question is, why are all of these attributes being captured about university? So why are you capturing all this information about university? Will it be necessary to store the founder and first president of each university? If not, these attributes should be removed from the ERD, because for every university, the founder and the first president, date founded, they will be same. So you don't need to record this information because this will be repeated. There will be repetition, so you don't need to record this in this entity. So this should be eliminated. Then if we talk about subject entity, the subject is name, description, and area. There is some problem in this entity as well. The problem is, although it looks correct, but there are certain problems. The problem is that the attributes in the subject entity are poorly labeled. Now the attributes are labeled as name, description, and area. But why we are saying that these are poorly labeled? Because for one, we have no way of knowing to which entity they belong if they stood alone. Like if we are given name only, we cannot say that it is a name of a person, a name of a university, name of a subject, name of a teacher. So to differentiate that it is name of a subject, we should add a sub underscore prefix with its name. Like it should be sub underscore name, sub underscore description, sub underscore area. So it will become more clear in that way. So it is required that you add, if there are certain attributes, mostly it is recommended that you add the prefix with all the attributes in that entity, the prefix of the entity title before the attributes, and most of the tools which are used to draw entity relationship diagram automatically do this for you if you are following them. The fifth problem is that the name attribute, like it's in the teacher, the name attribute really should be broken down into last name and first name. Like in teacher, if you can see that teacher ID number, teacher name, teacher start date. So the name attribute is mentioned as it is. So this is a suggestion that the name attribute should be broken down into last name and first name. Otherwise, there will be no way to manipulate names in the system. For example, if you want to sort out your teachers using their last names, you cannot do it. So it's better to split these first name and last name fields over here. So that is important. Another problem is that this model assumes that a teacher, there can be problem in the relationships as well. Like this model assumes, if you see the relationships among different things, you see that the relationship among university and teacher is from one university can have many teachers, but one teacher can belong to one university. Okay, so this is the relationship. There is some problem in this relationship, which is that a teacher can only work for one university according to this entity relationship diagram. What about those teachers with joint appointment? There can be a teacher working in multiple universities, working in more than one university, like they are working in only one university and they are teaching some courses in some other university as well. So this entity relationship diagram cannot accommodate those teachers. So if you are making certain assumption on your own, so then you should avoid it. So an assumption should be stated on the model in the documentation so that the business rules can be confirmed. And if it is the rule in your organization that the teachers working in your university cannot work outside, then this becomes a business rule which should depict clearly in all your documentations. And if it is not the case, then your entity relationship diagram should be corrected. So these are some of the problems which you usually make in entity relationship diagrams, which should be avoided. Now, after making your entity relationship diagram, you go for normalization. So we talked about normalization in our databases course, and I hope the things are clear now. I skipped these slides in our face-to-face class, so I hope after reading the contents from database classes, these are now clear that the database is initially it is in ERDs initially in zero normal form. When you remove the repeating attributes and repeating groups, then it comes in first normal form. Then you remove the partial dependency, like when your entity is not depending on the complete identifier, complete primary key. So this is when you resolve this, it comes in second normal form. And when you remove the transitive dependency or derived attributes, move the attribute to entity in which their values are dependent on the identifier. Like in the example we saw in our face-to-face class of databases, we saw the example with the zip code, like street, city, numbers, and street and city were dependent on the zip code. So we made a separate address table to resolve this. So if you perform these steps here, and then your data becomes more normalized. So this is an entity which is unnormalized. You are keeping information about customer, about books, about store, about special order, everything in a special order. So this should be normalized. So having too many attributes in one single entity means it is not normalized, and there are many attributes which will be repeated. So you should avoid it. And I hope if you have seen these slides, these are now clear, because we talked about these normal forms. So now I want to know if you have any questions from these slides or from the contents we studied in our class. You are free to ask if you have any question about entity relationship diagram, and also about data flow diagram, which we studied in previous class. If you have previous virtual session, if you have any question about data flow diagram or entity relationship diagram, you can ask here. Okay, the about type of questions in the exam, I can tell you about about a few questions, like the kind of questions which can be. Although there will be separate sessions about midterm exam in coming week, in which I'll be telling that what are the things which you have to study for your midterm exam. But for now I can tell you about some questions which you can expect. For example, you may be given a question like you are given a scenario and you are asked to make a context diagram for that, or you are given a context diagram, or for example, let's see, there is one problem I just explored. I just saw. I'm going to put it in these slides. Like there can be a question like, you are asked to draw a data flow diagram to represent the following scenario. A cable TV operator receives an emailed repair request from a customer. The repair analyst reviews the request and determines the type of repair needed by accessing the repair codes file. So you can be given a scenario and you may be asked to make a data flow diagram for that. In this case, what you will be doing is, first of all, you will be making a context level data flow diagram. You will make a system as a whole, like you can call it your system, and then you will identify all the external entities who will be communicating with your system, like your cable TV operator, customer with an external entity, and then the analyst files the updated request and forwards the copy to the technician. So the technician will be external entity. The technician completes the repair and forwards the order to the quality control department. So the quality control department is another external entity. So the customer has to verify the problem has been resolved, updates the prepare order, and sends a copy to duplicate information. So you can expect such kind of questions in your midterm exam. So a question can be like this, or you can expect a question like, so I'm exploring some sample questions so that you can understand. Or you can be given a context diagram, or asked to make a level 0 data flow, level 0 DFD for that. So you can be given a question like that. Or since your paper will be containing different multiple choice questions and true false as well, so you can expect like if I talk about on the data flow diagram, so you can expect questions like this. I'll be telling you about these in our face-to-face session. I'm just talking about data flow diagrams, that you can expect questions like this. Unlike data flow diagram, which represent the physical components of an information system, system flowcharts can provide a more conceptual, non-physical display of the movement of data through a system. In data flow diagrams, circles are used to represent processes that take input and transform them into. A general rule is that certain processes may have the same name. So you can expect such type of questions. But the questions will be from the topics you have studied or the topics included in your book only. So you can expect such type of MCQs. So your paper will have certain MCQs. There will be certain true/false. There will be certain short questions and conceptual questions as well. So you can expect such type of exam paper. And in coming week, I'll be talking in detail about what we have studied so far, and what type of questions. I'm giving you some sample questions which you can solve to prepare for your exam. But that it doesn't mean that the questions, sample questions which I'll be giving, I don't mean that the exam will be from those questions. The questions will be just for your practice only. So you can expect similar questions in your exam as well. So any other questions? Okay, I'm turning my microphone off. I'm here. If you have any questions, you can text me and I'll answer your question. Thank you very much for being here.